beneath the hum of ship traffic and the chatter of marine life, another sound is emanating from the Caribbean Sea. It's far too low-pitched for humans to hear, but its signature can be detected from space. Scientists have never seen, or heard, anything like it. Located southeast of the Gulf of Mexico, the Caribbean Sea features a large basin bounded by South America, Central America, and the Caribbean islands. It's a critical cog in the global circulation belt, forming currents that feed directly into the Gulf Stream. But when researchers at the University of Liverpool decided to study the dynamics of the Caribbean Sea, they noticed something odd. We were looking at ocean pressure through models for quite different reasons, and this region just didn't work, Chris Hughes of the University of Liverpool told Gizmodo, explaining how his models kept yielding large, inexplicable pressure oscillations across the basin. It felt like a sore thumb. After spotting the weird oscillations in models, Hughes and his colleagues decided to see if they could observe the phenomenon in the ocean. Sure enough, they did. Combining pressure readings collected from the bottom of the Caribbean Sea between 1958 and 2013 with tide gauge records and data from NASA's GRACE satellite, the researchers discovered that the basin of Caribbean Sea acts like a giant whistle. You have a current that flows east to west through the Caribbean Sea, Hughes explained. It's very narrow and quite strong. Just like a narrow jet of air, it becomes unstable and creates eddies. When those waves strike the western boundary of the basin, they die out and reappear at the eastern edge. This phenomenon, flashily named the Rossi wormhole, was first described several years back. Scientists now know that waves of certain shapes and sizes will resonate when they hit that western wall, just as certain frequencies resonate when you blow into a whistle. In both cases, the resonant frequency produces a sound. But because the basin of the Caribbean Sea is so vast compared with an actual whistle, the resonant frequency is extremely low. It takes 120 days for waves to propagate east to west in the basin, yielding an A-flat tone that's roughly 30 octaves below the bottom of a piano. A pitched-up version of that excessively eerie sound can be heard. Dubbed the Rossby whistle in a paper accepted for publication in Geophysical Research Letters, the phenomenon can be detected from space owing to fluctuations in Earth's gravity field as pressure changes propagate across the entire basin. The researchers plan to keep monitoring the Rossby whistle, with the hope that the signal might be used to predict times of the year when coastal flooding is more likely. So, if you ever find yourself out alone at night on the Caribbean, and the world feels completely still, just remember, it isn't. The ocean is always speaking to you.